Now we're going to transition to talks on specific techniques. Next one is Chris Zacny.
Good morning, everyone. The deepest we have ever drilled on the surface of the moon was 3 meters. This was done with Apollo 15, 16, and 17. And the upcoming missions, they have limitations to approximately 1 meter. This particular drill called REBEL, so Rapidly Excavated Borehole for Exploring Lunar Subsurface, has capability to go beyond 10 meters or tens of meters. I don't think there is an upper limit. If you put more mass, you can actually go deeper than 100 meters. It doesn't look like a drill. Bottom left-hand side, what you can see is this thing sticking out from a lander on the left-hand side with drilled towards the bottom. So you don't see these, typical drill pipes that you would see on an oil rig. That's because this particular approach is called coiled tubing. You have a coil of metal tubing, sort of like a garden hose made of metal. And to drill down, you essentially physically, plastically deform the tube from this round shape all the way to this to make it straight. So that's how you're penetrating down. At the bottom, you have something called bottom hole assembly. And as part of the bottom hole assembly, we have motors and drill bits, and also instruments. We have dielectric spectroscopy probe, and infrared spectrometer, neutron spectrometer, temperature sensor, heater, camera, and everything else that you can stash. So as you go down, you can essentially do real-time sensing with sub-millimeter depth precision. As we're drilling down, we're using gas to blow the cuttings to the surface. And the top right-hand side, you can see one of the cold tubing systems that we're going to be flying to the moon in the next, actually twice, to Maracrisium and Schrödinger Basin as part of the ballistic heat flow probe. It's the same cold tubing, but it's significantly smaller. For scale, this is shoe size cold tubing that goes 3 meters below the surface using pneumatics to blow the cuttings out of the hole. And those same cuttings can be actually looked by lander-mounted instruments. And so that's, if you cannot put the instrument in a borehole, in a drill, you can put it below the lander, and those instruments can look at the cuttings as they're being excavated to the surface. So this entire technology has been in some part tested by, funded by NASA. The cold tubing is, it's actually red water that we're developing from Mars ISRU, hitting TRL 5 already and shooting for TRL 6 in next year. And cold tubing is obviously funded by NASA to fly to the moon. So, and bottom hole assembly is funded by CERVI with Jen Haldeman as PI. And we have a hardware literally 10, 20 feet away from me in the lab. So all of those, this high TRL, and the mission could be put together relatively quickly to go where we've never been before. Thanks.
Thank you.